Hello, everyone. Thank you so much for joining also from me. My name is Tsvetelina Georgieva. I am Executive Director and co-founder of DesignMorphine. Thanks a lot for joining also to our participants from all around the globe. So let's start with a short introduction of DesignMorphine. Pavlina, are you sharing or? Yeah. Great, thanks. Our journey as DesignMorphine started back in 2014, and through it we are able to connect with people from all over the globe, empower them, and fuel their passion for collaborative design. We had the privilege to have taught thousands of specialists and nurtured their progress in some of the biggest companies in the world. DesignMorphine is a catalyst for collaboration with people who we admire deeply as individuals and professionals. Our team is comprised of more than 50 talented architects and designers and number of collaborating organizations, which gives us a multidisciplinary approach to design and its education across a gradient of applications. We are a community dedicated to academia, but we are also all professionals who practice our craft daily, and this allows for great versatility. We also had the privilege to maintain prolonged collaborations with partners like the University of Architecture, Civil Engineering and Geodesy, as Pavlina mentioned, also Microsoft, Harvard, Logitech, Pininfarina, World, and many others. Some statistics: we have taught students from more than 84 countries, traveled in so many cities all around the globe. We have created many different projects on many topics. Our pedagogy surpassed the teaching of technical skills, since we always challenge our students to give their best. First and foremost, we are a community, and as such, we support our students' dreams and to empower them. Many have been accepted to universities like Harvard, the Architectural Association, SciArc, Angevante, or have been accepted to work at the Hachedic Architects, for example, big Foster & Partners, Nike, World, PlayStation, and many other reputable offices. Some past examples of our students' work on multiple scales and topics, like jewelry, architecture, installations, and many more. One thing always connects them, and this is the experimentation and unique workflows. As you can see, we also are heavily invested not only in the virtual world, but in fabrication. We also collaborate on product design with our partners, and one example here, the video was with Arturo Tedeschi. We created this suspension lamp called Horizon, which encapsulates a freeform 3D printed shape within a handmade glass shelter manufactured in Murano, Italy. At the heart of DesignMorphine actually lies computational design. It empowers designers to automate repetitive tasks, validate design choices with real data, and encourages a process-driven mindset that can be universally applied. What's truly exciting is that computational design transcends disciplines and scales, making it relevant across all design industries. By pushing the boundaries further, by blending diverse software and hardware, and by employing them unconventionally, we unearthed the most breathtaking and profoundly innovative design concepts.
Hi, from me too. I'm Pavlina Vardoulaki-Pryor, co-founder and creative director of DesignMorphine, and I'm here today to just share with you a little bit of our newest endeavor. We're super excited to share with you that DesignMorphine, in partnership with the UAC-EG, is now offering a PhD degree. We're just starting. This is the first time that we've had the opportunity to really have this opportunity to talk to you all about it. We are excited about this new endeavor. It is a PhD in Computational Architectural Design. The program is specifically crafted to be online. It is fully accredited and worldwide recognized by the University of Architecture, Civil Engineering and Geodesy, which was founded in 1942 in Sofia, Bulgaria. This is the first year of the program, and we have the privilege to be working with 9 incredible mentors who are with us today. And they will share with you their professional journeys and field of expertise. The program underscores the multidisciplinary approach, really merging again computational techniques and design principles to explore the interplay of design, technology, and innovation. And this approach is applied across a various of design disciplines, enabling PhD candidates to take complex design challenges and push beyond the traditional conventions. An overview of the program, as I mentioned, this is a Doctor of Philosophy in Computational Architectural Design. It's under the Faculty of Synthesis of Architecture with the other arts, Architecture and Interior Design. It offers 240 CTS points by our partner university, the UACEG. And the duration of the program is 36 months. There are several times during the academic year that we are able to accept new candidates in this academic year. As I mentioned, the program is online, and we do also have a lot of opportunities to gather and to work together, and to invite a lot of the PhD candidates to any kind of endeavors that we have in collaborations with our partner university or other endeavors that we might have during those 3 years. And the requirements are bachelor's or more than with 5+ years of architecture or master in architectural degree. And there are scholarships and discounts available. And we are more than happy to answer more questions about the program. But there's going to be a section towards the end of the presentations for an opportunity to ask you all about what are you thinking, and also if you have any questions regarding the program or application process. About the program and the milestones that it offers, it offers a flexible monthly mentor one-on-ones. There is a lot of flexibility there because it will depend on the PhD candidate and the mentor themselves to set the time and the day that they prefer to meet. And then there are quarterly progress presentations that will involve all mentors in the program and all PhD candidates sharing their experiences and their progress throughout the program. The milestones are based on basically the CTS point system, which is basically the European credit transfer system that all Europe is working with, and it is transferable to any other country in the world. There is a compulsory and elective part of the program. It is suitable for working individuals because of its flexibility. On the compulsory part, we have a dissertation that it's approximately 100 or 150 pages, publications, a minimum of 2. That could be part of the dissertation, quarterly progress presentations, as I mentioned. So these are every 3 months, and qualifying exam, which is in the 2nd year. The elective part of the program has to do with courses attendance and teaching experience and project completion that is relevant to the PhD research. So again, it has to do a lot with the interest and just, it gives opportunities for each PhD candidate to craft their own path in a way throughout the program. So the educational experience, and there are some unique aspects of the program that we would like to share with you. The distinctiveness of the PhD program lies on several really key elements. It allows students to venture in one of the 12 pathways that are available, and through them our program promotes innovative research and collaboration across diverse fields, blending architecture, engineering, design, and computation. It allows for great flexibility because it is crafted to be online, and it is suitable for working professionals. And on the other hand, there are opportunities for in-person design and collaboration during our study trips and design challenges and partnerships. We've had the opportunity during the past 3 years with our Master of Science program to have collaborated with Microsoft, Pininfarina, Logitech, visited the UACEG last year. Really great experiences to come together and to really push the boundaries of design and meet in the real world outside of the online portion of our studies. There is obviously access to world-class mentorship, fostering a collaborative environment for discourse and research support through one-to-one meetings and quarterly presentations. DesignMorphine's alumni have received elevated career prospects. We've seen now 10 years of work with a lot of students across the globe, and also is the 3rd year of our Master of Science program. So we've seen a lot of doors really opening for our students in eminent companies and universities that are driving the future of design. So our PhD obviously opens doors to academia, to research, but also to prestigious industry positions. Many leaders hold PhD degrees, and this applies again to academia, but also to C-suite levels in companies, as well as tenure tracks in academia. But the most vital part of all, it's DesignMorphine's disruptive nature and commitment to build a united design global network and community that will be part of the PhD candidates' growth and build them as leaders. We always keep in touch with our alumni, and we also post opportunities and work together even after graduation. So that's something that we are very committed to. Starting into and going a little bit over the pathways and what the pathways offer. I think it's very interesting. I think that we've gotten a lot of questions about them and a lot of interest. So I'm happy to go through a little bit of a glimpse of what these different pathways offer. They have to do with, again, just giving an opportunity to the PhD candidates before they apply to understand a little bit more different opportunities and where they can venture and create like a discourse and just where they can gear their dissertation towards. The pathways are 12, and there should be basically like the students at their application process are asked to pick one of them and then basically gear their proposal towards this pathway. So the first one that we're starting with in computational architecture, interior and product design. So it's a very vast net we're casting here. It is about this interdisciplinary exploration across design fields, something that we're doing like with the master's program, but here it's geared towards, again, dissertation and more thorough research. It is about computational tools or complex, precise, or efficient design. It could be about optimization of energy efficiency, material use, exploration of new visualization, simulation, and technologies. But also, as you're going through a lot of this material, like on our website, you can see more information about it and envision any of these pathways through your lens. And this is really what we're looking forward to see. Pathway 2, it's about robotic fabrication, structure, and materiality. So it's geared towards revolutionizing architectural fabrication for complexity and sustainability, robotics for fabricating complex building components and forms, precision, and integrate designs using robotic capabilities and sustainable materials and construction techniques. In pathway 3, we're looking into machine learning and artificial intelligence, machine learning and AI for design processes optimization, evaluating numerous design options and multiple criteria, creating responsive and adaptive designs with real-time optimization, and reshaping architecture and design with intelligent systems, something that is very relevant topic. Metaverse, virtual reality, augmented environments, again, something that has been quite interesting, like for the past years, and it has been accessible to many. Here we're looking more into immersive environments and how we're visualizing or testing design concepts, bridging digital and physical realms in the Web3 technologies, redefining architectural design through the metaverse, engaging interactions and personalized experience in virtual worlds. Pathway 5, it's about robotics, autonomous systems, and adaptive living models. So it's creating dynamic, responsive, and living environments through robotics, utilizing robotics and autonomous systems for adapting spaces, integrating sensors, actuators, and AI, revolutionizing architectural design for enhanced quality of life. And you can see how any of these pathways really is connecting to previous ones, right? So there is such a vast discourse that can happen through any of these. Pathway 6 is about new ecologies and biotech design, cultivating and understanding of natural systems, so low-tech, developing regenerative architectural solutions, utilizing living materials and technologies, embracing ecological balance and biomimicry, and fostering sustainable practices and symbiotic relationships with nature. Smart cities and technology, harnessing technology for sustainable cities, integrating sensors and data analytics, working again like with AI, harvesting big data, enhancing resource and service management, creative livable urban environments, revolutionizing urban landscapes through advanced technologies. When we're talking about sustainability, energy modeling, simulation, and prototyping, we are looking into integrating sustainability in design, looking into energy efficient buildings and systems, renewable energy sources and sustainable materials, testing and optimizing energy performance, and creating environmentally responsible solutions. Structure optimization, design for climate change and extreme conditions, designing for changing environmental conditions, resilient and adaptive structures, working with sustainable and resilient designs, long-term viability of the built environment. In Pathway 10, it's about design thinking and entrepreneurship in innovation and design. Design thinking for entrepreneurship has to do again with innovative entrepreneurial solutions, user-centric solutions, creating opportunities for markets, financially viable and sustainable designs. We were interested into venturing into that aspect of design and architecture, computational design, because we feel that it's quite relevant again and interesting like as a topic, especially because of the entrepreneurial nature of a lot of opportunities that architects and designers are seeking in this space, and understanding and going in depth into that field of entrepreneurship. Education and pedagogy in computational design, something that DesignMorphine has been very passionate about. Innovative teaching and learning methods, integration of computational tools in design education, experimental learning and interdisciplinary collaboration, critical thinking, problem-solving skills, and shaping the future of really design education. It's a very important discourse. to be had. And the exploratory pathway opens all doors to our PhD candidates. They can venture into any really emerging technologies, create connections between any of the past pathways and hybridize them, or come up with something that they feel that it's very relevant, new, exciting space that they can venture into. So we're very open to hear your thoughts. Blue sky, really, like on ideas here. It is challenging really the paradigms and embracing innovation, pioneering research journeys to shape the future of design, and it's encouraging curiosity, experimentation, and groundbreaking ideas. Some additional information, there's a lot to look into on the website, a lot of information and a lot of details that we might not be able to cover into the open day. Please have a look into the sections again with questions and answers. And if you're interested to apply into an application page, but keep in mind that you can always reach out to us through email at phd@designmorphine.com, or even schedule a one-to-one call with myself through Calendly. I'm really excited to hear from really new candidates, learn more about it, and just understand a little bit more where our community is coming from. This has been vital through the master's program, and also I've had the privilege to meet many of you already and hear like your stories, your interest. All these programs that we create, they are based on your voices, and I think that that's something that it's important to say. We are really trying to create take a new step and create the new age of design education into like what is really like relevant in today's world. So please don't hesitate to put any time on my calendar. I will be really glad and happy to meet you. And again, there is going to be a Q&A portion like of this meeting towards the end of our presentations. And again, if you're interested to hear more about DesignMorphine and what we're up to, lately, we really keep in touch, and we're very good in keeping really relevant, stories, and just sharing what we're up to through our social media channels, and especially Instagram. So feel free to look into like what is the newest endeavors. I think we have some really cool webinars coming for Halloween, and we'll have some more coming up. So yeah, thank you guys. Thank you. I'm completing my portion for just like giving an overview of the program. Again, we will have the opportunity to talk to you towards the end of the program, so stay tuned. For now, I'll just give the opportunity to our dean, who is with us today, the dean of the UACEG, Dean Orlin Davchev, who is here today to say a couple of words about the university. Yeah, we're just super excited to hear from him. Thank you so much for everything that you're doing, for pushing really like all these programs forward, for your curiosity and understanding, and like always like have this fearless drive like to really go into very relevant and future endeavors. So yeah, just wanted to say thank you, Orlin.
Thank you, Pavlina. It's a great pleasure for me to be with you today. My name is Orlin Davchev. I'm the Dean of the Faculty of Architecture at the University of Architecture, Civil Engineering and Geodesy, UACEG in Sofia, Bulgaria. And with our partner DesignMorphine, we have successfully developed and implemented the short master program, one-year program, Computational and Advanced Design, over the past few years. This gave us the courage to try to open our existing PhD program to students outside Bulgaria. And after this presentation, I'm so enthusiastic for the potential and opportunities to go ahead and to start the new beginning. Let me say a few words about the procedures, because we need and obliged to follow all the regulations, national regulations and internal regulations in the university. First of all, I need to say a few words about the doctoral program. This is one of the 5 accredited PhD programs at the Faculty of Architecture of USCG. This is the doctoral program Synthesis of Architecture with Other Arts, Interior and Architectural Design for the educational and scientific degree doctor. From the professional field, this is specific for Bulgaria, professional field 5-7, architecture, civil engineering, and geodesy. I need to say that the Faculty of Architecture is accredited for its main master degree in architecture by the Royal Institute of British Architects, RIBA. The PhD program is accredited by the National Evaluation and Accreditation Agency. The education of PhD students in this program takes place in the Department of Interior and Design for Architecture, Faculty of Architecture, UACG. Admission of PhD students. There are several forms of training in Bulgaria. Training for the awarding of the educational and scientific degree doctor is carried out in full-time, part-time, and self-study form of training. Full-time and part-time forms are physically present with an application exam and specific state funding. Due to the planned remote method of training and paid form, the specific doctoral program will be conducted in a self-study form. The training of PhD students of self-study training lasts up to 3 years, but this means that it can be also completed in 1 or 2 years by the PhD student. Application requirements and conditions of admission. Persons with an educational and qualification degree master from the professional field 5-7, architecture, civil engineer, and geodesy can apply for PhD students. That's why for now in Bulgaria, we have only one stage for architects and engineers in their master degree. There's only master without bachelor. So at the moment, we have sent an inquiry to the Ministry of Education and Science here in Bulgaria for possible expansion of the admission of PhD students also from areas of higher education 5, technical sciences, and area 8, arts. Of course, after the corresponding changes in the internal regulations in UACG. Let's see the application documents. PhD candidates submit the following documents: application to the rector for training in a doctoral program, a CV, an authorized copy of the diplomas for the acquired educational qualification degree, master and bachelor with the attachments, list of publication, if is there any of them, copy of citizenship documents, other documents of the candidates certifying their interests and achievements in the relevant scientific field, for example, some awards, certificates, and etc. Certificate of English language proficiency, and of course, photos. Enrollment in PhD. Candidates for self-study PhD students propose a draft for the dissertation and bibliography for discussion in the relevant department. This is Department of Interior Design. Foreign citizens are enrolled in doctoral studies by order of the rector of the university after discussion of the submitted documents in the department. and after this decision of the Faculty Council, without taking competitive entrance exams. Enrolled PhD students are assigned a scientific supervisor. This is a habilitated person. And each procedure, step by step, for a PhD training is followed by this order. First of all, we have department council. The second stage is faculty council. And finally, the step ends with the order of the rector of the university. The training process. The training of PhD students is carried out according to an individual study plan. The curriculum is prepared by the PhD students and their supervisors and is discussed and approved by the Faculty Council. The individual plan determines the direction of the doctoral studies and consists of a general study plan for the entire study period and a work plan by year. The individual plan consists of the topic of the dissertation work, the distribution of all activities by year, participation in courses, seminars, conferences, and other public scientific appearances, participation in research project, the stages and deadlines for preparing the dissertation work. And finally, we go to graduation. The educational and scientific degree doctor, PhD, is awarded to persons who have the educational qualification degree master after training in doctoral studies and successful defense of a dissertation work. The right of defense is acquired by a decision of the Faculty Council on the proposal of Department Council. PhD students who have acquired the right to defense are unsubscribed by the order of the rector of UICG. The defense of dissertation is in front of a scientific jury consisting of 5 habilitated persons in the relevant scientific field. This is, in short, all the procedures for this 3 years period. Thank you. I'm ready for questions.
Thank you so much, Professor Davchev. I think you very well described the program, and all the procedures. Thanks a lot for that. If we have some questions, or we should continue to the mentors.
If we have some questions, I think towards the end of the program, we can answer them because they're more towards the application portion of today's meeting. So let's maybe continue with our mentors, go through some of their basically basically their sessions, and then we can have some time and answer some of those. But yeah, thank you so much for Dean Davchev.
Thank you so much. So I would like to introduce David Stasiak. So please say us a few words and present yourself.
Thanks so much. Really super excited to be here today. It's for me a really definite honor to be asked to be a mentor for DesignMorphine. I've been good friends with many of the people at DesignMorphine for a long time and have followed closely on huge amount of respect for the work, and I know how successful the master's program has been and how empowered the master's students have been through it. And so I expect that this PhD program will just be an extension of that, and really excited to be able to participate. I'm going to share my screen. And is this visible to everybody? Okay, good. I guess I should go back to the beginning. Here we are. So yes, I'm David. I received my PhD from the Center for Information Technology and Architecture, or CITA, in Copenhagen, Denmark. My focus really has been in computational design, and the PhD focus was in complex modeling. It was part of a larger project. And I'll talk a little bit about the journey that took me there. I've always had a very close connection between research and practice. You know, I would say that the practice side has been my lead, but the academic side is obviously something that I'm very interested in design research. I currently work at Nike in the innovation group, so working in research and development. I'm the design lab director, which is part of the digital creation studio in the digital product creation group in innovation. My team focuses on exploring design through robotics and additive manufacturing, computational design, and things like design simulation and algorithm design. We focus on digital knit. We really live kind of in that space between engineering, design, and manufacturing. So we work in kind of this space where it's very hands-on in terms of taking digital and pushing it into the design space. Unfortunately, I can't really talk about any of it. It is very restricted. So there's kind of like a hard stop in the projects that I can share to the prior to the time that I worked at Nike. So I figured I would talk a little bit about my journey. I started out doing an MArch-1, which is a master's program for a professional degree in architecture here in the United States at Rensselaer Polytechnic Institute. I was very lucky that we had a studio that was a collaborative studio with CETA in Copenhagen during my last semester, which is where I became familiar with the good people of Denmark. And we worked on this particular project, which was quite fun. My role in this project really was, it should be consistent as a theme throughout, was in sort of really solving a lot of the technical problems around how you can integrate the design intention with the assembly, creation, CNC processes to make. So really taking Grasshopper and analyzing, evaluating, generating geometry and processing that geometry in such a way that we could really quickly make these highly detailed variable geometries, bring them to life, have children climbing over them at this music festival. It was really exciting kind of opportunity just at the very end of my school to kind of explore how computation can be applied in a real world kind of fabrication environment. This work really led me into my first major professional project, working with method design and subcontracting for a project for Trahan Architects, which is the Louisiana Sports Hall of Fame. Our job was to actually develop the entire steel assembly that would hold over 1,100 unique concrete panels in place. So the final results of the project turned out to be very, very beautiful work, you know, from the design of Trahan. But the challenge, you know, we often called it the sort of reverse mullet, with the party in the front and the business in the back. You know, we were in charge of doing the business in the back. So really using Grasshopper as an instrument for evaluating the geometry, integrating an understanding of what type of connection was going to need to be used, working very closely with the structural engineer to specify exactly what those details were going to be, and then to array those details throughout the entire interior. You know, here we're basically evaluating which type of connection is relevant for which type of panel, and whether it can be hung, whether it needed to be fixed in place, or whether it could be stacked and just held with a rack. And then obviously all of the structural details as well for the beams and columns. Very complex geometry as it was, you know, but it really just kind of drawing on the design system to specify. And these specifications were used directly for the installation, fabrication. You know, the actual workers who are in charge of putting everything together were building directly from the digital model that we generated. So part of the realization in working in this kind of project is understanding that, and this is really what led into my research project, is that, you know, any building of even moderate complexity is comprised or developed through a massive number of models. So you have a design model, you have a structural model, you have an environmental evaluation model. People may be familiar with BIM and the nightmare that it represents. But this kind of challenge of having a broad variety of models and finding how they can interface better really animated the research project that I brought into CETA when I began my project. I also really focused in my project in methodology. A large part of my contribution was not just kind of the work and demonstrating the data interfaces that can be optimized between interconnected models for the realization of a project, but it was actually methodological. And I think as a mentor, that's actually one of the things that I'm really interested in, is pursuing real deep inquiry into methodology, both for research and for practice. I implemented, and most broadly, this sort of research through design. So we were actually doing a series of design projects that were focused on design simulation, integrating material characteristics with the actual design process. That was how we activated the interfaces between models. This is just a few of the projects that I worked on. The overall methodology really considered experiment as the heart of the design. So we begin with sort of discourse and theory, define a problem domain, really go through the sort of standard experimental frameworks, but then within that further interrogate the use of things that such as design probes, which are, initial investigations into the problem domain and to formulate and state hypotheses. And those design probes potentially emerge into sort of digital instruments, which we then apply in the actual creation and execution of the experiment. Series of prototypes, obviously, that are going to further advance the inquiry into the experiment. And then finally, developing a sort of demonstrator, which sort of, proves or doesn't prove the hypothesis that we created. And then we return what we find in the evaluation back into the discourse. This is sort of the whole network of projects and engagements that my own PhD project went through, which is beginning, from these kind of instruments and explorations, and then finally is emerging in the publications that I participated in during my project. The first kind of major experiment that I worked on is this project called The Rise, which was in 2013 and was fabricated at the EDF, which is a foundation in Paris, right next to one of Philip Beasley's crazy animals over on the left. But you can see a quick video of it. The real aim for this project was to support the idea of using simulation. Whoops, this is actually too late. Using simulation actively in the generative process to inform the final geometry and to sort of calibrate and to specify the material system and assembly system that was going to be employed. So having a kind of integrated collection of models, here you can see that this kind of growth, which is the sort of animation of, or the driver of the whole project, was really thinking about how we can apply sort of living systems or simulate living systems. You can actually see that the bending as this sort of object is growing towards a light source is actually activating different kind of behavioral characteristics. And then actually the final result of that model directly informs the fabrication process. So what you have is you have the actual simplified mesh geometry is directly parameterizing the more complex assembly system. Jump back into the presenter view. Here we go. Yeah, so using tropisms and the sort of logics to employ an initial modeling. And then that initial model then goes into these much more complex details that sort of resolve and integrate the sort of material characteristics of the simulated material, the rattan, to sort of drive how we specify the sizing and how we orient and create the assembly system, which then goes directly into the CNC fabrication of all these different modules. And we're in again, with the model, similar to what we were working on with the Louisiana Museum, you basically have a digital model, and that digital model allows for you to sort of lay up the entire assembly in a way that is independent of sort of more traditional drawing systems. So it's very model integrated. Another project that I worked on there was called Stressed Skins. This is a dual layer, very thin metal stressed skin structure that was robotically fabricated and integrated the sort of material characteristics of steel in the design process. This is really an examination of how a model network, similar to any kind of model network, can be considered for how it integrates between individual elements in a way that's very efficient. So really kind of trying to embed the geometry with intelligence that can then be crossed over into a separate model and sort of reparameterize a model that is either ahead of it or even back behind it, so that we have these kind of interlocked and looping processes that ultimately iterate over a simulation of a growth into a analysis of the performance of the material through things like finite element analysis, and even going down into sort of microscopic studies of the material characteristic change that happens through the robotic working of the steel that we did. So here we're using, again, sort of digital model to actually directly drive the tool paths that the robot is going to be working the steel for, going through and living for an entire month in the basement in the robot lab, executing the actual fabrication of the steel. I'm sure that many of you can identify with that sort of commitment. Yeah, and then basically laying up a kind of double skin connected steel structure. And really the purpose, again, for my project was to sort of have the sort of tightest integration between the digital model and the actual fabricated result. And, you know, essentially kind of feeding forward from this digital space into the real space and using material systems as a way to interrogate that. Following my project, bringing back some of these findings into practice, I went and began working for Proving Ground. Some of you may know the Grasshopper plugin Launchbox that's written by Nate Miller. He's the founder of Proving Ground. He and I were working very closely together. And here in kind of more prosaic fashion, you know, going back into practice and working just sort of in regular construction, kind of taking the idea of embedding geometry with intelligence in a way that is more lightweight than sort of traditional BIM. This is a project that we helped execute the virtual simulation of construction on, using Grasshopper and a series of software tools that we developed ourselves. We continue to work in this kind of frame, and we're developing a series of materials that actually built interactivity between Rhino and Revit in the realization of some complex projects. Here we're working on two projects, which now I don't have to show so many renders anymore, finally, which is great. We have the Gilder Museum, which is at the part of the American Museum of Natural History in New York. We work very closely with Studio Gang in the development of the geometry for the interior, not only its development, but then also capturing it effectively through models that could be represented and fed forward into engineering and contractor and to the engineers and contractors. Also working very closely on developing fabrication algorithms for the paneling system and the facade. You know, very, very kind of tight integration with the designers, but also feeding forward into the sort of contractors and fabricators. So again, kind of using computation as a way to sort of leverage intelligence that's embedded within the design concept to feed forward properly into these kind of complex assembly systems. And the same kind of work again for the Lucas Museum of Narrative Art, designed by Mad Architects, which is now finally really getting kind of closer to completion. You know, with these kinds of very difficult and complex geometries and assembly systems, having these kinds of modeling pipelines that feed forward from this sort of very gestural design and into the more complex fabrication instruments and assembly systems is kind of where a lot of this research work has taken me in practice. And I think that's probably 10 minutes. Maybe I went too long. Thanks for the time and giving me the opportunity to share.
Thank you so much, David. It was amazing to hear your background. It's very impressive and inspiring for all of us, I'm sure. Now I would like to introduce Jose Arguez and continue with him.
Yeah, thank you, Svetlina and Pavlina, for having me and for welcoming me in this extremely exciting endeavor. I'm really happy to be a part of it. I think I'm going to be brief. I took Pavlina's email quite literally, so I prepared literally 2 slides because she said a couple of slides. I'll just begin, I guess, by saying a few words on myself. My name is Jose Arguez, and I'm a practicing architect based now in Paris. But I am also a writer, and I am also an educator teaching at Yale University in the US. And so I kind of wear three hats at the same time to the best of my ability. I trained originally in Spain with a 6-year architecture degree, and then went to New York to do my master's degree at Columbia University, and then did a PhD at Princeton University in the history and theory of architecture. So I am going to just share a few words about the part of my work that I think relates in a more relevant way to a PhD, which is my work as a writer. And so I'm going to just go ahead and share my screen here. So this is the first sort of major project that I did a few years ago. It was titled The Building, and it was really a 6-year endeavor that generated 23 events across the US and Europe, involving approximately about 400 people around the discussion on the building as itself a unit of discourse in architecture, and specifically focusing on discussing what it means for a building to embody a historically significant contribution to architectural thinking. So I have here just a little idea, a little map of everything that we did. Is just about 2/3 of it. We were basically at most of the top schools in the US and Europe, and we're, I think, very happy with how we managed to galvanize and sort of shake the foundations of architectural discourse for, as I said, about 6 years. So the main outcome of that was this book, 415-page book that we published with Lars Müller, came out in 2016. And if you're interested in knowing a little bit more, learning a little bit more about the project, you can go into the website www.building.info, and you have a little bit more about that. Second book came out more recently, end of 2022, in Europe, and beginning of this year in the rest of the world. And it's titled Spatial Infrastructure, which is essentially a collection of essays that I've written over the past 15 years, so basically since the beginning of my career as an architect and a writer, around a new concept in architecture, spatial infrastructure, which is basically meant to serve as a catalyst for imagining new spatial modalities when conceiving buildings. This is more, as I said, more recent, and I'm basically now in the middle of doing also lectures and events between Europe and the US, and see what the response to is. And the third book, which is going to come out next year, if everything goes well, is going to be about the notion of form as spatial organization, discussed on the basis of a number of experimental sciences, primarily chaos theory, morphology, and topology. So basically the idea that one can sort of expand the boundaries of how we understand form in architecture by looking at fields on the margins of architecture, and particularly a number of sciences that developed exponentially and dramatically since the 1970s. So I don't have obviously a cover for that, but hopefully you will see it come out next year. And I guess I'm going to wrap up with a few thoughts on what the significance of a PhD is today, which I think Paulina also mentioned in the email. And I think primarily for me, that is twofold. On the one hand, you're basically trying to make a contribution to knowledge, and in making a contribution to knowledge within specific fields, you are not only expanding the boundaries of that field, which is extremely necessary and sort of a categorical imperative for every field, whether we're talking about the hard sciences or the soft sciences or the humanities or architecture or even the professional domain. And in doing so, what you're achieving yourself is basically to grow both creatively and intellectually, right? So it's basically an enterprise that has a two-way direction. It goes outwardly in a sense, in that it makes this contribution to an outside, to a field of knowledge, but inwardly it makes you grow intellectually and creatively with the incredible impact that has for yourself as a human being. So I recommend everybody to do a PhD. Everybody who's interested anyway, and I would do it all over again. So as I said, very excited to be a part of this. I'm looking forward to working with some of the prospective candidates in the future.
Thank you so much, Jose. It was great to hear also your thoughts regarding how important it is to have a PhD nowadays. So thanks a lot. And the next mentor I would like to introduce is Natalia Lima.
Hey everyone, how's it going?
Hi, Natalie.
Just sitting up here, give me 1 second. Hello. Yeah, I'll just give a brief introduction about myself before I jump into the slides. So I'm Natalia Lima, I'm Australian. So I studied architecture in Australia, and then I did my master's at IAC University in Barcelona. When returning back to Australia, I began working for quite a well-renowned architecture firm, designing building facades and multi-residential skyscrapers. Yeah, shout out to IAC, as David wrote in the chat. And you know, I always felt like a distinct disconnect between what's happening in the academic realm and what's happening in like the real world of architecture. You know, I remember thinking when I walked into the architecture firm, like, where's the parametric design? Where's like the robotic fabrication? Like, I don't understand how there's such a big jump going on here. So, you know, with a passion for wanting to really return back to academic research, robotic fabrication, and parametric design, I returned back to academia to work for those who know his name, Roland Snooks's lab at RMIT University. I also began teaching the master's course at RMIT University for architecture, and then simultaneously started my PhD. So working with Roland's lab, I really became really skilled and fascinated in computational design and large-scale 3D printing for architectural installations. But for my own research, I really became interested in generating feedback systems between biological materials, computational design, and robotic fabrication. So I began to look at sustainable 3D printing. So how can we 3D print with nature-made products? So how can we 3D print with like clays, mycelium, excuse me, slime molds, algae, and things like that. And I really became interested in how to orchestrate nature through computational design and robotic fabrication. So upon completing my PhD, I began to think, okay, how can I like apply now this research from the scientific lab to the commercial industry? And then I moved to LA here in America, and previously working for the Yeezy team within Adidas, and now working for Adidas. Similar to David, I'm not allowed to show any of the work that I do at Adidas, but what I'll run through today is just a few slides, what I did in my PhD, and basically the research that I do in my own design practice BioLab, and basically the research I'm interested in doing with my PhD student here in DesignMorphine. I'll just share my screen, give me 1 second. Okay, let's put this full screen. Okay, I'll just start with one of the projects here. So this project here I did within my PhD. This one's called bioscaffolds. So this is the idea of orchestrating natural growth through robotic intervention and computational design. These 3D printed scaffolds were 3D printed with a wood-based filament. So again, exploring ways to 3D print with natural polymers. And the robot here is actually injecting a liquefied culture of mycelium into the biodegradable scaffolds. So what the robot here actually is doing is it's reading and detecting where the mycelium is growing within the scaffold and then injecting additional mycelium culture. So what I really became interested in here is this idea of slow botics. So when everyone thinks of robotics, they think of like fast machinery, like mass production, similar to how we think of like how cars are constructed, we think of like robotics. But here I became really interested in this idea of like delicate movements over a long period of time. So how can a robot actually tend to nature over a long period of time and do these like delicate, slow movements to inject the mycelium culture? So I'm a huge science buff. So I became really interested in how to grow mycelium. And then here, just looking at how mycelium grows in nature and what food it's attracted to. It's attracted to wooden-based polymers. So that's why you see like mushrooms growing on rotten wood within the forest. So I began to think how to mimic that chemical reaction and then apply it to the realm of like robotics. So here you can see, let's minimize this. Here you can see myself injecting the mycelium culture into wooden 3D printed scaffolds. So here's just a catalog of all the 3D printed scaffolds pre-mycelium inoculation. So as I mentioned, I'm very much interested in orchestrating natural growth through robotic fabrication and computational design. So here are a series of heterogeneous skins that vary in porosity, density, and scale. So certain areas of the scaffold are designed to promote mycelium growth, and certain areas are designed to hinder mycelium growth. So that's why you see the forms ranging from like lattice systems to these like 3D printed antenna feelers to smooth surfaces to porous surfaces. Here's just a close-up, a few images of these. So this is just the empty scaffold 3D printed with wood. And here I just want to show the image. So on the left, we have the empty scaffold, and on the right, we have during the mycelium's inoculation. So here you can see the mushrooms almost growing with the digital antennas, fabricated antennas of the scaffolds. And some themes that I'm quite interested in exploring within my research is this blurred boundary between the natural and the artificial realm. So when you look at this scaffold, you think, is it computationally designed? Is it robotically fabricated? Is it made with nature? Is this something I just found in the forest? And creating that blur between human-made and nature-made is something that I'm really interested in exploring. And again, this idea of orchestrating biological growth, so having these specific growth patterns of the mushroom growth is something that I'm quite interested in doing. Here you can see the mycelium always growing through the fabricated feelers of the scaffold and then fruiting mushrooms towards the end here. And this image here is actually the scaffold post mycelium growth. So this is what it looks like when the mycelium completely adopts the computational shape. And this image here is quite important because this is the idea of creating these bespoke patterns of growth that you wouldn't ordinarily see in nature. Just some renders of the scaffolds. And one thing that I'm really interested in doing with my potential PhD students is this idea of creating these like really bespoke computational forms. My design aesthetic and my design style is really going back and forth between different softwares to create the sense of ambiguity of where the form is generated, or which algorithm you utilize, which computational design program you utilized to create this kind of new design language. And then here are some more of the digital versions of those scaffolds that I showed earlier. Here I'll quickly show, I'm also interested in this idea of applying research to architectural building facades, so actually having an application rather than these like small scale artistic sculptures. So here, myself and the lab were looking at applying this research to internal wall panel systems. So how can we utilize mycelium to replace synthetic materials such as foams and plastics? So here we utilize mycelium as a structural binder for these 3D printed skins. So this idea of having like minimal wastage for wall panel systems and utilizing mycelium as a natural sound absorbent for the internal house. Here's just a colleague of mine just showing the scale of the wall panel system, which is about 2 meters high. And here's just the computational algorithm we used to ensure all the draft angles were correct for 3D printing. So again, I'm not just interested in mushrooms. I'm interested in exploring a range of biological materials, such as creating kombucha leathers or orchestrating slime mold growth through like certain anchor point systems to create these bespoke, intricate screens. Another thing I'll quickly discuss is this idea of exploring different methods of 3D printing. One thing myself and the lab were exploring was 3D printing in a vat of gel to eliminate the need for a structural host system and really pushing the boundaries of what geometries we could achieve through 3D printing. And this last project I'll quickly show is 3D printing, rather than 3D printing a scaffold and then applying the mycelium, I began to think, how can we actually 3D print the mycelium directly? So here is the robot showcasing this customized mixture of clay and mycelium. And as you can see here, so this mixture was clay and mycelium, hemp, coffee grounds, and paper pulp. So here I fabricate these series of like intricate vases almost, or like columns. And what's really interesting here is rather than having like a static 3D print, these things actually grow and morph over time. As you can see, is like fluffing up and becoming hairy, something you wouldn't see in 3D printing. So I thought that was kind of cool. Something I can show that I'm currently exploring now that I'm in the commercial industry and applying this knowledge to fashion and shoemaking is this idea of how do we replace the existing petrochemical materials within fashion, such as foams, with nature-made materials. So here's just a artifact that I've been developing of this of a mycelium slide and the mushrooms growing. Excuse my ugly foot, but here's just a image of like how it actually can connect with the foot as well, and how you can possibly put different uppers on the foot, on the mycelium bed, sorry. So this is the final slide. Just wanted to showcase this idea of what I'm interested in doing with my students is having this scientific research, but applying them to architectural applications. So how can your research be a temporary architectural installation that biodegrades back to the earth, or how can it be a product of a shoe, or how can it be like a vase? And that's something I'll explore with the students. Yeah, so that's about it from me.
Thank you, Natalie.
Thanks, guys.
Thank you so much for for all the information and everything you presented. It's really impressive, and I'm sure your students will be super happy working with you. And next one, I would like to introduce Dustin White.
Okay, hi everyone. Thanks, Pavlina and Svetlina. Good to see you guys. Been a little while. Nice to see these inspiring lectures so far, and it's really great to be a part of this group and to teach in this program. Let me share my screen, maybe make sure I get the right screen. Okay, so you see the... Okay, you don't see my notes, correct?
No, we see only the screen.
Only the slide. Okay, good. Okay, so I'm gonna just have a little bit of a different presentation because I'm gonna present a little bit about who I am as a teacher and as an educator, and just kind of go over the kind of cross-section of the different type of work that I do, and then kind of finish off with some of the current research that I'm doing in my PhD. I've been teaching for something like a little over 12 years now in a number of different institutions, from starting in Texas at Texas Tech, moving to New York, where I was the director of digital technologies and fabrication. I was also an associate chair for a brief time of the undergraduate department. Now I'm currently I'm currently an associate professor of structural design at Florida Atlantic University. where I'm working towards building an innovative structures lab. So my work over the years has been really based in computation, digital fabrication, and then working on curriculum to integrate these technologies into the school and across the disciplines that we work with, whether it's architecture, interior design, art, depending on the type of school that I've been in. So I've, kind of taken now a role from moving towards administration, moving towards more full-time faculty, to focus more on my research. As an instructor, I've taught, as I said, in multiple institutions, but I've taught across sort of undergraduate, graduate, and interior design programs. I think I've taught something like 16 different courses, coordinated most of those courses, ranging from design studios to visualization and modeling, computation, digital fabrication, interior environments, and furniture design. So I guess I'm sort of maybe a jack of all trades, but maybe a master of none in some sense. Now I'm trying to become sort of a master of some courses. So, I've taught the prototyping lab in the MS degree for DesignMorphine. I've taught urban design courses in Verona, Italy, robotics courses at NYIT in New York. I would say, a lot of my work has really kind of been based in a research-based design, looking at sort of material computational strategies, where I'm interested in how technology, craft, and materials come together in ways that explore the boundaries between design, architecture, and other disciplines, specifically the pedagogy of these material-based computational strategies, supporting the integration of form, material, and structure by incorporating physical form finding strategies and digital analysis and fabrication processes. So in this approach, I think material often comes before shape, with material explorations as the premise for making and fabricating and design decisions that emerge from the results of the material experiments and the testing. So there's a sort of feedback loop of, testing material and see what happens, and you kind of go back to the computation side. So the work produced, by my students and myself really seeks to challenge digital technology and fabrication to further the relationship of material to machine and material to design, with the intent to develop and employ sort of novel software techniques that aid in sort of the translation from the virtual world to the physical medias that we engage through craft and technology. As I said, I was a former director of digital technologies and fabrication, so I built a number of labs across these institutions. The latest was at NYIT, which was, a more traditional fabrication lab with wood shop, laser cutting, robotics lab, clay lab. And then I did something similar at Texas Tech as well. And now I'm doing it for the third time at Florida Atlantic University. So it seems that I have this MO now of building labs, but not really using them and moving on to the next opportunity. So here's kind of an example of a collaboration that we have, developing sort of a 3D printed or a 3D print end effector for a robotic arm. This is similar maybe to Natalie's work, where we're trying to work with sort of bio-based materials and produce sort of formworks or scaffolding for maybe mycelium, maybe other sort of healthy materials. So I think that's where my research and my practice is going, is looking more at the healthier side of material practice and understanding that a lot of the materials that we work with or we use on a daily basis or interact with are potentially putting off VOC and or harmful and or toxic. So, I think we're all trying to kind of look at a more sustainable approach and a more healthy approach to material practice. In terms of my work, I've had work kind of featured in the Biennale, this being a sort of prototype for an urban plaza. So this is sort of one section from that. So we work with sort of a number of Italian artisans, whether it's working the stone or, printing on large kind of format ceramic panels, to working with some of the best artisans in Murano for the Murano glass pieces. And then my kind of collaboration and ongoing collaboration with Pimar limestone in the Puglia region of Italy. I work in my practice in exhibition design. So the image on the left is an exhibit that I designed and built for Meljac. Meljac is a French luxury switch maker. This was their introduction to the US market. I do kind of bespoke and one-off pieces of furniture. The sort of isomorphic star table is currently in a showroom in Las Vegas. So I have a number of pieces sort of in Miami. I have one soon going into New York, but this was actually one that's in production now. It's not quite this design, it's a little bit of a simplified version, but these sort of nodal structures where I work with foundries and work with showrooms to kind of build these kind of bespoke pieces. So in this kind of luxury market, I would say, you know, this market is sort of challenging to kind of crack into, and then takes sometimes a very long time to sell one of these pieces. Just another kind of example. For a number of years, you know, I worked with sort of kind of lightweight structures, interactive structures, you know, these kind of interactive environments where I was sort of embedding sensors, Arduinos, and other technology to give these sort of sensory-driven environments that were responsive to the users who were engaging them and interacting with them. This was sort of going back to 2015. But I think this sort of started some kind of the early sort of trajectories of my research of trying to, you know, work computationally and then find ways to kind of output and fabricate and construct these environments. And so everything kind of started lightweight, and then everything started to increase in scale and increase also in the material longevity, which you'll see in a minute. This was Stereoma installation for an exhibition at NYT that supported Stereotomy 2.0, which I co-organized with Giuseppe Palacara, who's really a master of stereoatomic stone construction. We had work that was featured from Foster Partners, Philip Block, Zahadi Code, which is the kind of chair that you see in the back. So we work a lot in stone. The kind of concept of this particular project was stereoma, which is this sort of thin-like veil that separates sort of us from the heavens and the sky. So this is kind of the conceptual idea of the vault construction or stereoatomic construction, but in sort of a lightweight interactive material system. Just a few photos of that project. I would say sometimes we have to work on a very limited budget. So this is something that was produced for under $700. So we had to be very innovative in how we used material. Sort of another example of this process, you know, taking what we were learning in from Stereoma and then bringing that then into the classroom, and then, you know, teaching my students and working through this process with my students so they understood kind of the minimal surface geometries. They understood how to, you know, how they could execute the nesting of the files, the full workflow of production, programming Arduinos. So this is all from the first time. These students had no experience. These are kind of a mix of undergraduate and MArch students. I'd like to see the video. This kind of built up to my work in stone, which is really where I think a lot of my passion is and where my current research is going in stereoatomic construction. I think this was, you know, the precursor to where I am now with the Coral Table, which was a commission piece for the Marmamuck Stone Theater. The Marmamuck is the largest sort of stone exhibition in the world that happens every year in Verona, Italy. I was invited to produce this in collaboration with Generelli, who is really a premier sort of stone fabricator, Swiss-based company, but Italians. Milled from a single block of stone through kind of robotic fabrication processes. So I think the importance here is, you know, when you're working in this type of material, you know, you have to work with people who understand this material. So this is, for one, the very key component here, because we're milling for something like 16 hours a day for almost a week straight. And then it goes through sort of post-finishing for another week or two. And so it's a very labor-intensive process, very complex process. I think what we learn from this is that when we work from a single block is we incorporate or we achieve a high amount of waste. So, you know, something like 1 to 2 tons of material waste, which is, you know, not responsible on a large scale, but is pretty common in stone and the stone industry across the world. And so I think that, you know, kind of set up some of the kind of latest research. You know, I think, you know, in 2022 in the summer, when diffusion modeling and AI started becoming on the rise with Midjourney, DALL-E, Stable Diffusion, I, like many, started to kind of jump into that trend and see, you know, what is this all about? You know, how do we begin to collaborate and work, you know, closely with AI? This sort of led me to work with a company called Concrete. Concrete is sort of a premier sort of 3D printing specialist. They have a specific process of using stone waste. So we're not using sort of virgin material, but we're taking the waste or a byproduct from the industry and then using that as a printing process. And so this is really where my current PhD is right now, and looking at additive stereotomy. And so these are kind of a series of, I'm not going to go kind of too in depth on these particular projects, but more about my research and looking at how we can use an additive process in stone to build up into real sort of projects. And so I'll just kind of go through these a little bit. We can watch the video and kind of see a little bit of the process. So Concrete's process is all binder jetting technology. And so any of you who have ever worked with Z Corp, it's a very kind of similar process. I guess the challenge of this particular process early on with kind of going from image or text-based design process was, you know, finding a way to kind of model and achieve that surface. So this was just a series of relief surfaces looking at Gothic detailing, and then a kind of recomposition of those details in a kind of an illogical composition. So here we see a little bit of the binder jetting process of Concrete. Where we are now is that, you know, the scale here looks a bit limited. So some of these projects have to be executed in a number of kind of small parts. Now we've scaled up the technology, and we're working with a machine that is about 4 meters by 3 meters by 3 meters in depth. They also have a machine in production that will be 6 meters by 3 meters. And so now we're talking about the scale of building components. These few slides that I'll show about kind of current projects that I've worked with Concrete on are more for exhibition purposes or more proof of concepts of looking at the material. But where we are on the back end of this is starting to study the material and study the material's compression strength and viability in the element to see how it withstands being outside, for example. And what we understand from the compression strength right now, at least from the material of limestone, is that it has almost the same compression strength as a block taken from the earth right now. So this is very promising. I'm just going to jump ahead to the latest work, which is Technovault. This was just another kind of proof of concept looking at sort of vaulted pavilion design. Again, sort of working collaboratively with kind of a series of AI software. And I kind of collaborate with one of my colleagues, Daniel Bolajan, who's really an expert in AI right now. So I have the benefit of you know, utilizing my colleagues at the school that I'm at. This again printed with limestone. Maybe the video is a bit more interesting because it gives you kind of an overview of what we're trying to do. From working from the byproduct or the waste, I think the real challenge of the material system is having to sift the material to get to the right micron level. We can print at different granular levels, but it does affect the overall strength and composition. What we like is that the material from PMAR limestone is really a great sort of consistency, and it's really like set up well for 3D printing. So there's not a lot of like extra or added work to set it up for printing. So to give you a sense, the model that you saw was about 15 different parts. It's about 164 centimeters long and takes about 4 days to print in total. So it's a very fast process. So once we move to the bigger machine, that print would take about 4 hours. So it's a very fast process. And so now we're able to achieve sort of a resolution in stone with the pattern that, is, really unattainable from any kind of robotic process or any other kind of machining process in stone right now. Okay, and I will stop there.
Thank you so much, Dustin.
Thank you, everyone.
It was amazing seeing your work and super impressive what you are doing with the stone. Thank you so much.
Yep. Thank you.
Next, we are having Gazal Javidania. Hi, Gazal.
Hi everyone. It's nice to meet everyone here, and it's really privileged to be among these professionals and the DesignMorphine family. I'm going to share my desktop. There we go. Okay. I think you have my desktop now.
Yes.
Can you see?
Yeah.
Okay, great. Thank you. Yes, my name is Gazal Javidania. I'm from Iran. And I hold PhD in architectural design. It's less than 1 year that I have been graduated. I have held my PhD from TAU University in Tehran, Iran, and I have been 1 year in Technical University of Eindhoven in Netherlands as a visiting researcher. I divide my journey in architectural design and how I get to computational design in 4 steps. The first step was when, for the first time, I faced with the parametric design. I learned parametric design, visual coding with that, Grasshopper in Rhino 3D, and then I go further and learn Python and C programming. It was like a magic for like about 10 years ago. For the first time, I faced these tools. And after a couple of months working with that, I figured out that it's not just the simple tools of design, like another 3D software. It was a game-changing tools, and it was also a method of design, because with parametric design, we could have hundreds of thousands of different various alternatives from one single sketching or one single algorithm. And that was the first step that I figured out that this is something new in architectural design field. And after getting more familiar and with parametric design, mainly I work with Grasshopper and just a little with parametric design in Revit Dynamo. I confront my first question that how we can choose different alternatives between these hundreds of thousands of solutions. And that was where I processed to my second step in my journey, that was figuring out the power of computational design. In this step, I try, experience, and research on different parts of computational design. As a method of design, I learn how to use generative design and how to use data to drive my design. I work with several simulation and analysis plugins, several simulation and analysis software that can join with Grasshopper. And also I work with multiple optimization algorithms, while I focus on genetic algorithms and meta-heuristic optimization. And additionally, I practice with some artificial intelligence algorithms, machine learning oriented design algorithms like CNN and GAN, and designing a plan in a buildings plan. After these steps that I could figure out what is the power of computational design, what different methods are this in this computational design, I go to my third steps, applying this method to develop my research area. My research area, or mainly my PhD thesis, was funded by Tehran municipality. It was a tall building design guideline for architects. And of course, it was seismic awarded design because Tehran is one of the most seismic region of Iran. So we were supposed to propose for architects who was going to design tall buildings in Tehran, a guideline, a simple guideline to teach them, to show them how to use generative design, how to use simulation and analysis, and how to use optimization algorithms to define a framework for controlling the very different, complicated, and complex parameters that you confront when you want to design a tall buildings. And yeah, I'm not going to go very detail of this research because we publish every detail of what we did in many reports and research papers. We publish many papers in journals, conferences, and we had held many workshops, national and international workshops, to explain the detail that how we use these different methods to propose the tall building seismic award design framework for architects. The journey of my PhD or my education was finished here, but not myself. Last year, I was the visiting lecturer in Iran University of Technology in Tehran, and I decided to get all these theory I work, research, and learn about building design and lateral stability, structural stability, and material study to the practice era. So we decided to fabricate one of these beautiful and magic forms that we always design in the computational design courses. So we designed a 3D shape arc inspiring by the catenary algorithms. And then we work on this with different materials. We simulate and analyze different structural stability and its weight and the possibility of fabricated by hands, because we just have students and we just want them to be able to fabricate this because we had a very, very big twist on the top of the form. And the bounding box of the form was 3-4 in width and length, and of course 4 meters in height. So we studied different materials, and finally we chose polycarbon 1 centimeter thickness, and we designed all the details of each pieces in the grasshopper, and then to laser cutting for fabrication. And one things that we do, because if we want to make this thicker, which we need for adding a stiffness, it was really difficult to fabricate that with hand, because the students need to make those twists by their hand. So we add these semicircles around the boundary of each piece to maximize the stiffness while keep the thickness as small as we can for handmade fabrication. And yes, we did it. We fabricate what students just design and simulate in 1 semester. It was 1 semester of design in our computational design course, and 4 days of fabrication and build. And yes, now I am working as a visiting and adjunct lecturer in multiple university in Iran, Tehran, and different cities. I teach in multiple course, and I work as workshop instructors, and also advisor of some master students, and hopefully mentor for some PhD students for DesignMorphine. And I also work as consulting for multiple design studio companies in facade engineering and in computational design for pre-study, simulation, and analysis. I try to keep it short. too. Thank you for your time.
Thank you so much, Gazelle. Thanks a lot
You're welcome.
for sharing your experience with us. Next, I would like to introduce Mahmoud Tantush.
Hi,
Hi.
can you see me?
Yes.
Hello everyone. Sorry, I thought there was one more person before me, so I'm caught off guard. Thank you very much for inviting me. I'm looking forward to seeing what comes out of it, really. I've been impressed with the previous presentations, and hopefully the it's really enriching to see the diversity. So hopefully my presentation will be an interesting contrast to what has been presented already. So just 1 second while I share my screen. Can you see my screen?
Yes, we do.
Yes. Okay. So I'll just start with a bit of information about me. So I'm Mahmoud. I'm a lecturer at the Manchester School of Architecture. In the US, that would be equivalent to an assistant professor. I'm a core researcher at the university, and I work with a research lab called Complexity Planning and Urbanism. And my interests are related to urban analytics, smart cities, machine learning for research, urban planning, and understanding cities through big data. Most of my presentation will be formulated around my PhD topic, and that's working with tweets to understand urban activities. So hopefully it will be a good kind of introduction to doing a PhD. I think what I think Jose mentioned earlier about doing the PhD and the significance of contributing to knowledge is something that is very important when you're doing a PhD. So I just want to emphasize that point. I also work I founded a company to develop computational tools for design. And I also teach computational generative design at the Manchester School of Architecture, but that's not my main research. My main research focuses around spatial temporal data and analyzing it using machine learning. Just going back, so as part of the lab, we have a large academic network spanning different continents, and we work with funded research projects. So this is one of them, which is called DACAS. And it's a research network where we collaborate with Brazil, Japan, UK, China. This is some of the computational design work we engage with at the MSA in terms of teaching. Our approach to computational design focuses on new ways of design as opposed to kind of construction, which is different from what was previously presented. And this is a quick example of some of my previous work where I was analyzing the impact of Airbnb on gentrification in Manchester. Of course, when you're engaging with a PhD, you're expected to publish your work because otherwise it remains secret and not useful to everyone else. So, and this is how you contribute to knowledge, right? So you should be able to kind of formulate strong theoretical drivers for your project and be able to present them as research outputs that you can share. Right, so onto my PhD. So hopefully this will give you a interesting overview in terms of what you might be working with if I will be your mentor. But my main theoretical focus of the PhD is around understanding urban space and how the digital kind of interacts with it. So by using GPS and mobile phone data, we're creating digital traces in the city, right? So theoretically, how do we work with these digital traces which are invisible, we have to access? And how do we structure the data and how do we analyze it for us to extract useful knowledge that we can use to understand urban behaviors? And this is towards urban planning and management. So the knowledge that my PhD seeks to kind of figure out using a case study in Manchester is urban activities. So what are people up to in the city? Where do they meet? and how does that pattern of activities change over time and across space. Again, I don't want to go deep into this, but using theories of complexity, so how do people sort of organize and how to understand emerging patterns becomes something very important. And when I say theory here, it's really a way for us to think about the problem and analyze it, because that's what will enable you to contribute to knowledge, is to advance theory primarily. So as part of the methodology, I collected tweets over time. This involved programming scripts, so working with scripts such as R, Python, HTML, JavaScript, etc. And how do you basically interact with Twitter servers and collect data over time? So engages in a very intricate process where tweets are collected on a weekly basis and then are automatically cleansed to maintain anonymity and to maintain the GDPR standards. This is a basic introduction to Manchester City Centre. So as you can see, there's different quarters in the city, and each of them have different inherent functions. But hopefully you can see that there's a main spine of the city here called the Oxford Road Corridor, and there's different quarters. So this is where mostly the shopping centre is, cultural quarter is. We have the gay village over here and some of the two main campuses in the university. So through this, I engage with a bottom-up analytics methodology, which means working with machine learning to help me structure and analyze the data without any preconceived knowledge. So what does the data tell me about the city using these methods? And this involves working with machine learning to cluster tweets over space and time using different parameters, and also language processing, so using an LDA model, which stands for latent direct allocation. How do we understand the content of those clusters semantically? And then this involves also working with language models, right? So how do we model different topics coming out of a body of tweets? So it's a very complicated process, and it's not something that exists as a method you can do. So I had to build my own tools to kind of visualize and understand how tweets are distributed and think about how to cluster them and analyze them. So this is just a very simple kind of demonstration of kind of under the hood what's happening in terms of analyzing these tweets. And ultimately, we get this very complicated overlapping kind of functional traces of a city, right? So a tweet in itself doesn't inherently tell us what's happening in a city, but analyzing them collectively and structuring them does. And the ultimate output here is really to understand how cities function, right? So by using the language model, you can see where people are going for cafes and desserts, music and nightlife, family and friend celebrations. So these give us an indication of how the city has been used. And I've just showed these. There's a lot more work and outputs here, but I'm just showing this as a snapshot of kind of how to understand different parts of the city. But also interestingly, over time becomes a very important thing, right? So the tweets, when I was working with them, I started collecting them prior to the pandemic. In the UK, there were multiple lockdown measures, so we can also see how the lockdown impacted where and how people interacted over time. So space and time become very important things for us when we're working with cities, because policy and management relates to planning in the future, but also understanding how it's being used. Yeah, that's it for me. Thank you very much for listening.
Thank you so much, Mahmoud. It's true that we had several very impressive presentations, including yours, and also it's totally true that we have a great diversity, and it's super interesting to hear about all the mentors. And so we can continue with the next one, Solomon.
Hi everyone.
Hi.
Have a good year. Thank you for having me. I'm really grateful to have this opportunity to work with amazing people, and I'm gonna just try and share my screen so I can show you a little bit about what I am about. Hopefully you can, nope, can't see that. One sec. Okay. Can you see the presentation now?
Yes.
Great. So, similar to Mahmoud, I work with him at the Complexity Planning and Urbanism Lab in the Manchester School of Architecture. I'm also a lecturer there and teach in undergrad and postgrad. My research interests very similar to sort of a lot of other people, but especially moving a little bit beyond that is urban simulation generally. So human behavior. So a lot of us as architects try and design buildings that are aesthetically pleasing or have some kind of uniqueness to them. And when designing these things, I was looking into the value of design and realized that the way value is calculated in a lot of established methods is essentially proximity and size. So I refuse to believe that what we do is just boxes in specific locations. So I tried to, through urban simulation and GIS modeling in my PhD, to understand how can I best quantify some of the qualitative aspects of design that we sort of engage with as architects and produce. So how urban simulation deals with different urban aspects relating to spatial change over time. So spatial planning is the premise of urban models because urban models act as tools for planners. So when making decisions, so the spatial planning itself is the coordination of practices and policies that shape spatial organization. So control of people and activities, distribution over spaces of various scales. And as architects, we almost fall into submitting into what strategic planners approve for certain areas. So those create our briefs. So urban transformation is the change of urban morphology over time, the change of socioeconomic patterns over time, change and the cause of that change in the urban realm. And there's different ways of researching this change. I mean, we can measure it. So there's deductive research. So we measure spatial, social, economic change over time and deduce relationships that might exist within it. Or you sort of look at the space, social norms, and economic context, and you sort of see how it affects people who then change space, social norms, economic context themselves. So it's inductive research. What I do is simulation, which is a third way of doing research. It's alongside inductive and deductive, but it has an alternative set of ontologies and epistemologies. So it drives a model of a system with suitable inputs and observing corresponding outputs. So basically, it has many ways of being used: prediction, performance, training, entertainment, education, proof, and discovery. And you will see some examples later on of how simulation has been used in different forms and different scales. Mainly, what I do is computational simulation. So I drive a digital model that's concerned with abstracting behaviors of one or more groups of agents and placing them in a digital world to see how they interact. There's different types of simulation, and each one is used differently. So, for example, prediction could be used to validate a theory. Proof simulation is used to investigate concepts. Discovery to discover relationships and principles that may exist in an urban system. So, depending on what your research is about, you will use this tool or this method of simulation to investigate a different aspect of it. So my unique focus of urban simulation, at least the one that I've worked on in my PhD mostly, is agent-based modeling. So it includes a range of agents interacting with each other in a set of predetermined behaviors. So change is driven by the bottom up rather than imposed from the top down. So if you consider that, we're thinking about individuals making choices about moving around the city, or which house to buy, how do they commute to work, things like that. So these these decisions drive how the system responds. How do we model our infrastructure? How do we create, where do we place things? And what do we include as a sort of criterion for our buildings? So agents are autonomous entities which are situated in a specific environment, and they have the ability to monitor and actively or proactively and reactively respond and communicate to each other. And they all have a theory that's based, that sort of tries to specify how they're represented in the digital world. It's a blueprint of how we are creating these agents in a model. And they have what's called an agent architecture, which is the specification from from moving from the theory to the implementation within the model. So how do they reason? How do we code their logic, and so on and so forth. And there's various ways there's different architectures like logic-based, where this is a simulation that we've made on autonomous vehicles being tested in the terminal of Manchester Airport against taxis. So how can these new technologies be introduced, and how do they compete in a resource competition model against other sort of established modes of transport? So they go and pick up passengers, take them to the city, and vice versa. And we can track every single passenger, every single vehicle, and then we can compare them accordingly over time. So how do they perform against each other in various dimensions, including waiting time for the passengers, CO2 emissions, and so on and so forth. So this is logic-based architecture. And then we have things like reactive architecture, which if we think about things reacting to having predetermined relationships that are mapped as reactions, depending on what other people are doing. So if we think of a flocking bird simulation up here, and we can establish that in a sort of platooning effect when we're designing road infrastructure. And then you have other aspects like cognitive architecture, which they have memory and experience. So then we're going into AI and intelligent agents, which is what my PhD was looking into. How do we incorporate intelligent agents in order to understand how they view qualitative aspects of design, how they value different aspects of design. So I'm going to go into some examples here. So in this particular example, it investigates a generative design science-based method in order to create an emergency hospital system deployed during an epidemic, which simultaneously isolates patients and is comfortable. So it's a computationally driven building system of parts and enables rapid and optimized deployment of pop-up hospitals in the event of pandemics. So agent-based modeling is used to test the spread of diseases within this hospital, and ultimately optimize the arrangement of the wards and the circulation in order to reduce the spread of diseases. Here we have another one. It was during COVID. So it was pandemic resilient cities. It was the idea that how does urban morphology and how we design our cities actually affects the spread of diseases, and can we through the use of smart positioning of proximity as well as urban form mitigate the effect of spreading of pandemics within our cities. And obviously we create and run several simulations in order to understand, depending on the type of disease and its effectiveness and so on and so forth, how does that change over time, and how resilient the city is towards it. This is a little bit more building level, where we're creating and simulating sound. So how do you create a soundproof material and through design in order to minimize external noise pollution for the building, and also optimize the location of programs based on noise generation and requirements within the building. So the simulation, the agents here were actually the sound waves, depending on the activity, and you're sort of testing the different calibrated material shapes and forms in order to optimize towards mitigating that. This is an agent-based model regarding policy. So this was a right to buy policy, where people who engage in the UK in affordable housing, so the city council provides housing for people who are not able to afford it, and then through this policy gives them the ability to buy the house over time. And depending on several factors, it tried to understand how and who would be able to buy it based on income and so on and so forth. So this deals with data feeding into the agent decision making and analyzing how far can it go. This was something that was actually published in a recent sort of chapter in a Springer book. This deals with agent CA modeling, so cellular automata. It's about changing the temporal order of things and then seeing what effect it will have over time. So the City Council has a strategic policy where it will approve certain types of development, but this research proved that it's not just what you approve, but the order by which you build it that has a massive effect on the overall outcome that you're trying to achieve within a city. So, if you were to place education first, it will have different outcome than anything else. This is a simulation that deals with trying to establish a zero carbon future city. So there's a web-based tool that you can look at the different iterations, creating visual representation of the different performance criteria. So if you go into futureurban.net, you'll be able to see it as well. This is something that's created in order to understand and give the users the opportunity to choose between different iterations while giving them the option to view their performance and sort of make a choice, because no iteration performs brilliantly in everything. So the complexity of the decision making falls not on the designer, but it falls on the stakeholders. So this tool enables a communication and dialogue in a sort of collaborative planning sense. And then, of course, we've been doing some things that deal a little bit more into science fiction, and this is a space colony with a series of typologies as connectors. So you have a residential pod, an agriculture pod, and then they all need to exist in a certain ratio in order to make this colony work. And then adding to it over time, there's a growth process. So you create the rules behind this process in a three-dimensional city building simulation, effectively. So yeah, these are some examples of the work that I've been doing. So yeah, thank you very much.
Thank you so much, Solon. It was amazing to know more about you and to see what you shared with us. Another very, very impressive presentation. Thank you. And last but not least for today, we have Sara Kudarin.
Hello everyone, give me just 1 second. Hopefully you can hear me all right.
Yes, we do.
That's great. Sorry, because I'm out of town, the connection is not great. Can you see my screen? Can you see everything?
Yes, yeah.
Okay, sounds great. Perfect. So hello everyone. I'm really blown away by all the presentations that I've seen today, and I echo the excitement, and thank you so much for including me in this cohort of amazing creatives. So my name is Sara Kudarin. I'm currently an assistant professor of architecture at Lawrence Technological University in the Detroit area College of Architecture and Design. I graduated from the University of Ferrara, Italy, where I also hold a PhD in technology of architecture, and I'll speak a little bit about that later. But yeah, just to give you a little bit of context, my university is located in the Detroit area. We have a close relationship with the industry, with the culture of manufacturing. There's this idea that is sort of depicted here in Diego Rivera's mural at the Detroit Institutes of Art. There's this idea that sort of manufacturing and the production and the culture of production and the understanding of certain spaces of labor are part of the local heritage in a way. So it's interesting to see that connection happening, and us try to leverage these aspects in academia and through our teaching. This is the place where, like, at the Ford Museum, the first industrial robot is located, and the tools that we use in the school. So I'm sort of responsible for the technology sequence in the curriculum. We do use robots. We have classes in robotic fabrication, and oftentimes those tools come from the industry, come from assembly lines, and they sort of have a second life in school. So we really oftentimes talk about how these tools are becoming more sort of affordable and available just in different contexts. And again, trying to keep the conversation going related to those things. So it's a university that focuses a lot on teaching, and we filter research through teaching. I do teach an intro to robotic fabrication class. It's sort of an expectation that every student in architecture understands how to speak machine, how to operate within these workspaces. And so really having a large cohort sort of develop with the students quick weekly assignments, sort of to understand the logic of those machines, to understand the kinematic in space, to leverage three-dimensional space, and recently also using ChatGPT, AI platforms sort of to produce codes, looking at mathematical functions and see how that gets translated into the three-dimensional space, in this case, using light painting, model making exercises, just as a way to think about objects as a sequence of operations, right? Like thinking about how I design a kinematic, how I design the motion of a robot and the axis to sort of accomplish the desired outcome. So like trying to develop in the undergraduate level this system of thinking. And then creating opportunities for sort of space making and thinking about those objects that we're making with the students as sort of proto-architectural forms that sort of hold opportunities for occupancy and for human interaction. Now that was mentioned before, it's very important to be able to publish, to disseminate any research we conduct, and I think it's very relevant, especially in this context within this PhD program. So here's just a publication available for you guys in case you want to sort of go and understand more in detail some of the approaches that we deploy at the college. I'm very interested in sort of spaces of work. I'm interested in the relationship between humans and machines. I taught last year a VR course, an elective seminar with Professor Carl Daman, in which we explored basically the role of the body in making space. So using Gravity Sketch, natively digital line work, and forms and subdivision modeling, sort of to understand the occupancy of the body, the proportions, and how all of these things together sort of relate to space, and trying also to model surfaces to understand again the occupancy of just the human articulations, and 3D printing some of those outcomes out of the studies of motion. And then ultimately also keep pushing this idea of using subdivision modeling for creating fluid forms, and try, to get to understand this kind of models, surfaces, and volumes, and how we can interact with them. And also ultimately thinking about like this methodology as a way for building spaces of domesticity. So how a domestic space will look like if we only sort of analyze it through the lens of human occupancy, like based on the motion of the human body in space. One thing that I care a lot about is sort of the use of automation in conjunction with craft. So I know that and it was mentioned before, when we think about robots, we think about speed, we think about precision, but I'm also interested in adding kind of idiosyncrasies in the processes and try to obtain unique outcomes, especially working in the 2.5 space, that I think there's a lot of kind of space for debate in that kind of process, and in that kind of also space for manufacturing. So recent project in which I explored line work in the 3-dimensional space and see what happens when sort of the implementation becomes 2.5D. And also seeing the role of iterations in this kind of process, and understand, like in which instances you start to lose certain information or gain different kind of knowledge. The lines might sort of I know embed information about the directionality in which the drawings were made, but also thinking about that's the 2-dimensional translation versus having exhibitions online in the metaverse and looking at those objects in their original nature as like 3-dimensional digital artifacts, and exploring some of those things also. 2.5D space has an opportunity also to sort of like adding materials in the conversation, using biopolymers to look at sort of a bio-oriented future, but also sort of to keep making artifacts that are like that sort of embed this nature of translation from one world to another. So kind of like switching from the drawings into more material 3-dimensional outcomes, so to speak. Another publication, so sort of covers some of those approaches and those things that I've just described, that I talked about. In just a few words to mention the fact that I also collaborate with a startup that does 3D printing using concrete or concrete-based materials, and sort of using the setup in our lab to sort of do form finding and trying to understand, the translation from the physical model or scale model into full scale kind of implementation. So looking into those things. So it's also potentially exciting to think about PhD student that could collaborate remotely with us, having remote access to some of these tools to sort of carry out PhD research. So another publication available if you are interested in exploring more. And just would like to conclude with some recent explorations that sort of start to include text-to-image AI in the conversation, always keeping like the interest for understanding spaces of labor. As I mentioned, I did a PhD in Ferrara. Was more like a speculative work, thinking about the use of robots for architectural restoration. And now, especially in this past year, was compelling to me, really to being able to visualize some of those things, some of those speculations, and thinking about the machines interacting with cultural heritage as sort of agencies for space making and for, adding a layer of technology into the sort of process of taking care of the collective heritage. And this led me to current seminars that I'm teaching within the college that sort of deploy text-to-image AI, we say for like creative thinking, for storytelling, and really using this as an opportunity to try and visualize the future of work, to visualize spaces of work, spaces of labor through the lens of text-to-image AI. So using these opportunities really to leverage creativity, and also looking at cinematography, looking at opening scenes of iconic movies, trying to understand the structure, how they work, what what can we learn from that? What are the techniques deployed that we can sort of translate into text prompts that allow us to create sort of like efficient and actually effective storyboards for storytelling, kind of this approach that led to some world building that takes into consideration future-oriented approaches. And I will leave you with this sort of last slide that talks about the possibility to envision futures in which machines sort of create humans. And hopefully that was kind of quick, but hopefully I covered some of the content that I'm excited about. So thank you again for the time for being here.
Thank you so much, Sarah. We had amazing presentations, like literally I'm blown away. I'm sure that most of you. Just to mention that Lenka Petrakova is another mentor. Unfortunately, she couldn't make it today. So she's the 9th mentor for the PhD degree.
Yeah. Thank you, and thank you for mentioning Svetlana. Thank you everyone really for sharing your design journeys, your expertise, your contributions to the world of design, architecture, engineering, and computational design. It's been really amazing to see all this body of work. It's very inspiring. We're very excited to have the opportunity to really work with you all. We want to also open the conversation and the podium to some of our guests today, our students and people who might be interested to learn more about the program. So feel free to ask any questions that you might have in the Q&A section or the webinar chat. Like they could be like towards our mentors, or I know that there are always like some questions about also the process of application and you know, some things that like you have in mind. So feel free to ask us anything that you have in mind.
I see one question from Elitsa Dimitrova. Can we have more than one mentor?
I think that one is for me, so I'll go ahead and answer. So the mentor is going to be one like for the program, but you will have the opportunity to work with more than one really like person or like one mentor during the program. As you saw, there were one-to-one sessions that you will have the opportunity to have with your mentor and meet with them every month, but then quarterly, so every 3 months, there are presentations and discussions and discourse that it's with all the PhD candidates and all the mentors included. So you will definitely hear back. You will, you know, like engage into meaningful conversations with the whole team that it's engaged at the time, which it's very positive, and you will get a lot of great insight to and different perspectives.
And another question from Jeff. How would you organize things like robot lab access during the PhD program for the students?
Well, that's an interesting question. It's not, it depends on, again, like the dissertation and the work that you're trying to achieve, right? So if there are any opportunities about, again, study trips and working like in any kind of robot lab, like we will try to facilitate in the best possible way. We do work with a lot of great companies, and we have established these very long-term partnerships through the years. So it might not be, again, day-to-day access, but we could definitely look into facilitating some of those. Also, that's a great question, and it is important to mention that the PhD candidates are free to foster and create their own collaborations. So if there are opportunities like for external funding or working with certain company that the PhD candidates might be interested into venturing into and working with closely, it might be close to where like they live. That's also something that it's highly encouraged. We are actually in discussions with several companies, engaging their interest and seeing if they might be open also like in collaborating like more with like some of the candidates. So this is a discourse that like needs to happen from both sides, and it's highly encouraged.
We have another question, like it's similar. Is there a network of labs students could have access to, or is that something? Just thinking that some of the research will include fabrication and other physical projects.
Yeah, I think it's the same in the same space. Like the question, again, there are going to be students from all over the world, and because it is an online PhD degree, we have to like take into consideration like and just create opportunities like for travel. If we have need to fabrication processes, or look into again fabrication labs that are near where you are if you are going into this type of research.
Another question from Azmi: would the PhD dissertation will publish in Scopus journal?
Well, there are a couple of publications that are required as a minimum, like for the PhD degree. They could be part of your dissertation or closely related, and you can choose the place where you would like to publish them and present them throughout like your educational journey.
Yes, and Scopus is for sure amazing opportunity to do so.
Do we have any questions also for our mentors or any of the research or presentations that you guys saw?
Maybe I could just read some of the questions and answers that have already been done by Professor Davchev. Just very quickly, are we allowed to pick our new topic for the thesis? Of course, you can choose your own topic as long as it is in the indicated pathways, but as you see, our pathways are very broad, so you have a lot of opportunities. Do we choose the pathway before or after starting? Before you start in the application form, you need to select the pathway and also to mention your topic in advance. And after that, of course, after you have been enrolled, you have the chance to discuss this topic with your mentor and moving further. But yes, it should be done in advance.
This is this is a good question because again, like we present also your proposals, like when you're applying to the mentors, and we're trying to find the best possible person that is excited to work with you, and it's just that's their focus of their work. So in the general scope, that's what we're looking into. Of course, things might change, and of course, like there is a lot of knowledge that you accumulate, and there is an opportunity like to talk to the mentor and change some of the ideas or alter them, and this is inevitable because like the first thing that you will be doing is looking into the dissertation structure. So many ideas are going to come into play like in this phase. So it's absolutely natural, but for us it's important to understand what is the broader topic of research. That's something that it's good for you to really do some soul searching before coming into the program and proposing, because that's what the broader umbrella, it's not going to change. Great. Okay. If we don't have any other questions,
one more. How will the course be organized to be flexible for working students?
well, that's the beauty of this PhD. It's because it's online and because it has a lot of flexibility. It's really geared towards working individuals. Well, the candidates are meeting with their mentors monthly, so this can be negotiated, right? Like the window that of meetings can be negotiated between the mentor and the mentee. It could be at any time or hour or day, like depending on, again, availability of both and what is comfortable for both. So that's great flexibility, I would say. And then the next part, it's about we are always being very mindful about like when we have collective sessions. So that's going to be like in the program, like when the collective sessions or quarterly presentations, as you saw them, are going to be held there. A maximum of 4 hours that they will be as duration of these sessions, and they are the ones that the students are going to be showing progress. And when I'm saying progress, also this is important to mention, it's not only dissertation-based progress. It might be that in 1 quarter, there might have been a huge leap and advancement into the dissertation, and like we can look into this portion of the work, but it could be that, again, there was an attendance of courses or design or research, like portion of work that, again, can be shared. So it's any really like step forward like towards the work of the PhD and the overall umbrella that we're really looking forward to hearing from, like in these sessions. And that's where the flexibility comes from, because again, the one-to-ones are absolutely flexible, and the 4-hour sessions about presentations where all the mentors who are engaged in the program, like can have mentees at the time, are going to be engaged with everyone and hear your feedback, but that's going to be in a time zone that it is comfortable for everyone in the world. I think that in the masters we have really like learned a lot about this topic and how to really like place meetings that are, somehow like comfortable for everyone, like no matter like their location. We do the best possible.
We have another question from Walter. Can you discuss what type of courses we'll have access to?
The courses that you will have access to through the program have to do one about academic writing. So that's something that it's important to us for you to understand how to structure your thoughts and just follow the guidelines and, like of how to structure really your dissertation. Courses on a technical level, we will be opening the Master of Science tutorials. So everything that it has been pre-recorded from the Master of Science program is going to be accessible to the PhD students. So that's something that you can benefit from and watch at your leisure. And any kind of additional courses that you might be taking, again, as electives, right? Like that's going to be, again, depending on the topic of dissertation, it's going to be something that the candidate needs to venture and find on their own, because again, like it's going to be strictly probably like related to what their dissertation is and their topic of research.
Perfect. Do we have any other questions? Yes. Would it be possible to extend the duration for the working students?
That's a good question. I would say that the PhD, we are trying to complete all the work like within 3 years, right? Like that's our idea. That's what we're really, like care about, like in DesignMorphine, that we don't prolong this as a lifetime, like endeavor, which does happen in academia a lot of times. So we do want to hold you accountable into meeting really like your, milestones, I would say. It's very important, like for you and for us. And that's where, you know, like, again, the quarterly progress comes in. That's where the one-to-ones comes in, you know, like, because again, like, it's going to help you structure your thoughts and move forward faster. Because this, again, you know, like, being comfortable and knowing that you can finish in 10 years, you know, like, it's not really helpful in any endeavor, really. But it's good to mention that, like, you have the flexibility, right? Like, if you are not ready on the third year, that's totally fine. But after the third year of studies, you will be self-studying. That means that, like, you will have to just complete your dissertation, like, on your own.
And just to add to that, that basically you have two more years. So 3 years with us, and after that 2 more years. During these 2 more years, if you decide to take them, you need to present your dissertation. So basically the program is totally 5 years.
Yeah.
If anyone needs more time.
Yeah, there is flexibility on that too, which is great, because you don't need to worry about this portion if, you know, again, you don't hit exactly the 3 years, or you need a couple of more months, or you need to revise some of the work. But in the first 3 years, you are going to understand very well, like, where you're going and how you're, you know, like, moving forward, and how to structure, again, like, your work. So by then you should be comfortable enough, like, to move forward on your own with minimal really, like, overseeing with that time.
Any more questions, or if anyone else from the mentors or Professor Davchev would like to add something to the conversation?
Okay, so I guess we answered them all.
For now, yeah.
Yes, but feel free again, like, to reach out to us through the email, as we mentioned, phd@designmorphine.com. Also, as I said, like, you can find my calendar and always reach out, put some time with me. I'm always open to hear, like, again, like, where you're coming from, like, what are your interests? If you are interested in applying, like, and you have any questions that I can help with, I'm happy to really meet. So take advantage of this opportunity. I would say, like, it's always great for me also, like, to hear from you, but I think that it crystallizes a lot of questions when you're going through the process, like, when you can hear back and have somebody really look into your particular situation. Yasin Yosifov, that is also, like, with us today. He's our administrative assistant, so he is working a lot, like, with along with Svetlana and the university, like, to make sure that, again, all the processes are seamless, like, with the applications. So you're going to be hearing from him, like, when you email us. But yeah, thank you all really being part of this today. It was really a great pleasure to see you. It was a great pleasure to see, like, all the amazing research and contributions that you have done. It's really inspiring. We're really looking forward to the next step. And we also want to thank all our participants, like, for being here today, and for your interest and encouragement, and really for being our inspiration to move forward, create more, you know, like, programs, more ideas of collaboration and discourse. You're really our inspiration, where all these, you know, like, ideas are coming from. So thank you for all your love and support, and we're excited to get to meet some of you and work with some of you, really, like, in the PhD program. We have the first candidate starting very soon, in a couple of weeks, actually. So it's going to be super exciting endeavor. And we are also looking forward to some applications, because the next application process is going to be concluding around the 1st of November. If the start date is the 1st, or actually it's not the 1st, but it's in the beginning of January. So this is like the next steps from us. Thank you, everyone.
Thank you, everyone. It was amazing to be here today, to be able to watch and hear all the amazing work our mentors have done. It was super nice to see you all, and hopefully we'll meet very soon during the PhD degree. Thank you, everyone.
Thank you. Goodbye.
Bye.
Thank you. Bye.